All right, this is number 8. So with domain restrictions, you're looking for variable in the denominator, variable under a root, or the combination of both, which is what's happening this time. So the numerator x has nothing to do with it because that's not one of the restrictions, right? X in the top is fine, and that's not underneath the square root. The only thing we have to restrict is the denominator. So because it's a square root in the denominator, if it was just a square root, it'd be greater than or equal to 0. Because it's in the denominator, it's greater than 0. So I would get that x itself has to be greater than 0, which is all real numbers, such that x is greater than 0. And in interval notation, it would be 0 to positive infinity. Like, let's say it said square root of x over x minus 2, right? How does that change things? Now you've got a restriction in the top and the bottom, right? So this would have to be greater than 0. So on a number line, you'd get from 0 to positive infinity. Greater than or equal to, sorry. And then the denominator cannot equal 0, so x could not equal 2. Now you'd have a whole at 2. So in interval notation, that's from 0 to 2 with a parentheses on the 2, and then 2 to positive infinity. So if it's switched, then we got to worry about that x minus 2 because it's in the denominator. All right, so this was from the 2a. So I'm assuming you're good here, and yeah, you said you're good on those two, right? So when you get to the part C, it's g of t minus g of 2. So g of t is the actual original function, which I just drew over, but it was 5t squared. I think that's a minus, right? Minus 7t plus 6. And then minus g of 2 you found here. So it's minus 12. And then you just combine your like terms. We're going to do more of the combination of functions because you're going to see that a lot more when we get to 2-6, which might happen before the test, might happen after the test. If it happens after, obviously we'll cut it from the test. But you're going to see a lot more with the composite functions where we do two things like add them, subtract them, that kind of stuff. All right, so 2, 3. Okay, so 7 has 2 restrictions you got to worry about. The numerator, which says the square root of something, right? So what's underneath has to be greater than or equal to 0, and x has to be greater than or equal to -4. But then also your denominator can't equal 0, so x can't equal -4. So if I were to graph the greater than or equal to -4, it'd be a bracket pointing to the right, like that would be that one. But then the not equal 4 means I can include 4, and that bracket becomes a parentheses. So it's greater than, but not greater than or equal to -4. All right, so 2-3 is called analyzing graphs of functions. So we talked about it a little bit yesterday. Finding domain and range is something that we're going to learn how to do from a graph. We're going to learn how to find increasing, decreasing behavior from a graph. We're going to learn how to find like values of y that correspond with x's, all from graphs. So most of this is based on a graph. So we start with domain and range. We talked about it yesterday. Domain is all the values of x. So domain is my x, which means I'm going to go from left to right on my graph. The range is all the y values. So I'm going to go from bottom to top because you want to go from least to greatest. All of these answers are going to be given in interval notation. And then as a reminder on a graph, a solid dot is going to be the same thing as a bracket. And an open dot would be parentheses. So when that open dot means I can't include it, so it's going to get a parentheses. That solid dot means you can't include it, it's going to get a bracket, okay? So we're just going to talk about the behavior moving left to right and up and down to get domain and range. Then we're going to talk about increasing, decreasing, and constant behavior. To do this, we read the graph from left to right. So you literally look like you would read a story or read a sentence. You would start at the left and you would go to the right. If your line or graph is rising as you move from left to right, that would be increasing. If it is falling as you move from left to right, it would be decreasing. And if it's horizontal, it's constant. It will never be vertical because then it's not a function. So we're talking about functions now. If it was a vertical, it would fail your vertical line test, so it wouldn't be vertical ever. But it can be a combination of these three. And it can go up, then down, then up, then flat, then up, then down. It can change a lot of times. So you might have more than one spot that's increasing. You might have more than one spot that's decreasing. You might have more than one spot that's constant. Or you might even just have one of these. You might not have all of them. Again, this answer is given in interval notation, and it is open dots except if the graph starts or stops constant. So if a point is shared by both something that is increasing, so let's say my graph starts like this, but then it changes to be constant, and then it changes to be decreasing, even though these are solid points, well, and that's really, this should be very horizontal to prove my point, right? It's not perfect horizontal, but this part here would be increasing. This part in the middle would be constant. And this part on the right would be decreasing. So when I use interval notation on all that stuff, an arrow means either negative infinity or positive infinity. If it's pointing left, it's negative infinity. If it's pointing right, it's positive infinity. But then all these coordinate points in between, that one point technically is increasing and constant, and you can't pick. It's not like you get to choose which one it is. That point, even though it's a solid dot, would get parentheses. The only exception to it is if it starts constant, which means it would start at a solid point. It would move constant, and then maybe it changes to be increasing. This is going to get a solid dot. Or if it starts something else, let's say it starts decreasing, but then changes to be constant and stops constant, that would get a bracket. Those are really the only times you're going to see a bracket, is if it starts or stops constant. Anything else is going to be parentheses. All right, so we're going to do both domain and range and increasing, decreasing behavior. These are actually piecewise functions. This is what they look like when you graph them, because they're different graphs depending on the range. Let's start with domain. So remember, domain is all the values as I move from left to right. So I've got values of x for all of these and values of x for these on to positive infinity because of this arrow, which means my domain is going to go from, what's the first x that's there? -3. And it's going to stop at the next x, which is this, which would be 0. And then there's a break in my graph, and it picks up again at 2. But the arrow would point it forever in this direction. It's going up, but it's also going to the right, which would mean it's going to continue on to positive infinity. Now the open dot means parentheses. So the -3 is going to get a parentheses. The solid dot means bracket, so the 0 is going to get a bracket. The open dot on the 2 means parentheses, and infinity will always get parentheses. So my domain is in parts. Yep.
Do you do the union for this?
You can, but you don't need to. Yeah. The range, I think it will ask you for a comma on WebAssign is what I think it says to do. The range is bottom to top. So now we're working our way from the lowest y to the highest y. The lowest y, we have ranges this whole direction, which means from here to here, or from 0 to 2, there are y values. And then over here, it means it starts at this y and it continues up to positive infinity. So now we're saying 3 to positive infinity. And again, open dot. So this lowest y here is an open dot. That 0 is going to get a parentheses. The solid dot gets a bracket. And then the next y that's there is the open dot on the 3, which would be parentheses, and it ends in infinity, which always gets a parentheses. Okay, that's range. Now we want to talk about Xavier.
So is range just y?
Correct. Domain X, range Y. Now we want to talk about increasing and decreasing behavior. So I'm moving from left to right so that my numbers go in order from least to greatest. So as I move from left to right, this first little part of my graph, would I say that's increasing or decreasing? That's increasing. So it is increasing, and I only give the X values for the increasing. So it is increasing from -3 to 0. And again, a point itself cannot be increasing, so I put parentheses on both of those, even though that dot is solid. Increasing, decreasing will always have parentheses. Constant's the only exception. Then it starts again over here, and is that increasing, decreasing, or constant? Increasing. So it's increasing again from where X is 2 to positive infinity, and again, both get parentheses. There is no part of my graph that is decreasing. There is no part of my graph that is constant. All right, we're just going to do that on repeat. Go to the next one. So start with domain. Again, domain, left to right. So what's the furthest point left? Good, it's an arrow, so it's negative infinity. Where does that one stop? -2, bracket or parentheses? Parentheses, good, because it's an open dot. Then my graph stops and starts again at what x? 1, and it stops at, 1 with a bracket, because it's a solid dot, and it stops at 2, and it gets a parentheses because it's an open dot. So I went left to right on my domain. Questions on that one? Okay, then I go range, bottom to top. What's the lowest y on my graph? Negative infinity. Where does that part stop? What's the y where it stops at? 0, bracket or parentheses? Parentheses because it's an open dot. Then my graph stops and starts again at what y? 1, and it goes to, and it's got a bracket, sorry, because it's a solid dot, and it goes to 2, and that one gets a parentheses because it's an open dot. Now we do increasing, decreasing, constant. So again, we go left to right. Is this on the left here, that first segment or arc, is that increasing, decreasing, or constant? Increasing. So the arrow pointing down to the left does not matter. It's what direction it is as you move from left to right. So it's increasing from negative infinity to the x value where it stops there, which is -2. Increasing always gets parentheses. Then my graph stops, and the next segment is increasing, decreasing, or constant. Also increasing from the x that is 1 to the x that is 2, again, always getting parentheses. Only if it starts or stops constant. So increasing and decreasing never gets a bracket. Increasing and decreasing, all of that, you read the x values. Okay, go to 3. Let's do domain. So what's my furthest x? Negative infinity. And then it stops at what x? -3. Parentheses or bracket? Parentheses, good. Yep. So this arrow is going up, but it's also going left. It goes in both, so that's going to affect your range and your domain. And your increasing, decreasing. Okay, then it starts again at what x? -2. Does it get a bracket or parentheses? Bracket. And it stops at what? 1. And that one gets? Parentheses. Good. And then it stops and it starts again at 3. Bracket or parentheses? Parentheses. And it goes to? Positive infinity. Then I go to my range. What's the lowest y? One, right? These all are at 1. This one's at 1. It doesn't matter. If there's any point at 1, we count it. And is it solid or is it open? Solid. It is solid. Solid would overtake an open, right? Because open, if it was all open, obviously, then we would say parentheses. But if any of those points are solid at the 1, we say it's solid. I mean, which would be a bracket. Then what happens to my y values as I move up? This graph stops, right? But if I'm at 1 here and this arrow points up, that means it is all those values. I don't stop and start it just because this one stops and this one starts. As long as there are values of my graph that are included on that y in anywhere, we include them. So it's going to go from 1 to positive infinity because of the arrows. If this side was here instead of this, then it would start and stop. I'd have actually just one. It would be a bracket on just one like that. Then it would stop, and then it would pick back up at 2. Actually, it would have been a parentheses because it's open dot, and it would have gone to positive infinity. So if there was a gap, that's what it would look like. But this time, there was no gap. It went all the way up from the 1 and then arrows, so positive infinity. Okay, now increasing, decreasing. So this part over here, actually let me do a different color. What's that first path doing, that first part of the graph? Decreasing. From the smallest x is negative infinity up to negative 3, decreasing, always gets parentheses. Then it stops and my graph does this, which is what? Constant. And this time it starts with a solid dot. That's the only time you're going to get a bracket. Negative 2 to 1, but that 1 gets a parentheses because it's an open dot. And then the last section of my graph is what? Increasing. From 3, always gets a parentheses, to positive infinity. Yeah.
So we didn't have to name the other range because it was already included?
Correct. Yep. So like things like lines, if you think about it like a regular graphed line, domain's going to be all real numbers, and range is going to be all real numbers, and it is increasing from negative infinity to positive infinity. So things like that we didn't really go over, but that would be how it is. So like if it was with a negative slope, domain all real numbers, range all real numbers, now it's decreasing the whole time, right? And then the only other kind of line you could have, because it has to be a function, is a horizontal one. Domain is all real numbers. Range would just be the y. So if that's 3, my range is just 3. And it is constant the entire time. So it'd be constant from negative infinity to positive infinity. So you're going to get things like a parabola where it's a normal shape, right? And then you're going to get ones like these where they're piecewise, where it's chunked up, okay, where you have to start and stop. Okay, so do the first part, and then we're going to go back in and do what's underneath it. For you guys, do the domain, do the range, the increasing and decreasing constant behavior of these 3. And then I'm going to teach you how to do what's underneath. All right, so domain, I'm going to start with 4, right? Domain goes left to right. What's the first range or what section of your domain? Yeah. Yeah. Like the interval notation?
Or we can just like put it in.
You can put it in. Yeah, what's on the bottom? Well, no, you'll see when we need to do actual work. But this is just listing. So negative 2 to what? 0. Negative 2 gets a parentheses, 0 gets the bracket, right? Then it starts up again. Yep, because this is solid dot. Then it starts up again at 1, and it goes to positive infinity. The 1 this time gets a parentheses because it's an open dot. Questions on domain on that one? All right, range. What's the lowest y? Negative 4. If I go, and it gets a bracket. If I go from bottom to top, are there any breaks in my graph vertically? No, which means I go from negative 4 all the way to positive infinity with no break. Yep. So look at your graph. Like, although there are 2 separate sections of it, if you look vertically, right, from the lowest y, which is that negative 4, all the way up to positive infinity, there is a y value there for each. There's a point on your graph for each y value. So even though there's a break, the break is in the x and not the y. So let's say that this was up here. Let's say it was here. Now all of this would be a break in my graph. So I would go from, let me erase it, sorry. I would go from negative 4 to negative 1, then I stop, then I pick up again at 4, and I'd go to positive infinity because there's a break in that graph. But as it is, there's no break vertically. There's a break horizontally if I move from left to right, but there's no break vertically. So that range is 1.
Yeah.
Which part?
At any, like, what do you mean it's no y? Because it's not on the line.
Are there y values? Is there a graph for all the, so is there a graph at -4? Yes, where y is, right? Is there a graph at -3? Yes, because it's here and it's here. Is there a graph at -2? Yep. Is there a graph at -1? Yep. Is there a graph at +1? Yes, because that continues to move up.
Oh, because there's each.
So it doesn't have to be on the y-axis. It's anywhere on my graph. Are there values for that y? Does that make sense? Okay. All right, now increasing, decreasing. So that first little segment is what? Decreasing. And I give the x values. So -2 to 0, both get parentheses because parentheses for every decreasing, increasing.
Wait, you didn't give the range for the other one.
It's all one range. There's no break vertically. That's what we were talking about. Yeah. And then now this part of my graph is increasing. And again, I give the x values. So from 1 to +infinity, both get parentheses. Good. Okay, go to 5. My domain is what? This arrow goes that direction and that direction, which means what's true about my x? -infinity to +infinity. Yeah, but you'll put it in interval notation like that. How about your range? What's the lowest y? +1. Does it get a bracket or a parentheses? Bracket. And what's the highest y? +infinity. Okay, increasing, decreasing. So start for this left. This segment would be, or that section would be decreasing. The x would be -infinity to 0. And then my graph changes direction, and that would be increasing from 0 to +infinity. From 0. Because this is where it changes direction. That's where it starts to increase. It's the x value. Oh, increasing, decreasing is always the x value.
Yes, that's 1.
The x there is 0. This is 0. This coordinate point is 0, 1, right?
Oh, wait.
So you use
Okay,
you use the x value for increasing, decreasing. Okay, last one for this part. Okay, domain. So what's the furthest point left? -5. Does it get a bracket or a parentheses? Parentheses. Then if I look from left to right, there are gaps in my graph, right? So my domain's going to start and stop. So where does that segment stop? -3. Does that get a bracket or a parentheses? Bracket. Then there's a gap, so I stop and I start again with the next one. The x values on that would be what? -1 to 1. Which one gets a bracket? Which one gets parentheses? Parentheses. Bracket. Good. Then it stops again, and then it starts again at 3, and it goes to +infinity, and they would both get parentheses.
So that's positive?
It doesn't go straight down. So if it went straight down, it would fail your function test. It can't go straight down. So even though it looks like it might be, there's a slight curve on that. If it didn't, it would fail your vertical line test, so it couldn't be a function, and these will all be functions. For the y, not the x. So it's going to the right and down, which means the x is going to get bigger, but the y is going to get smaller. It's going to take some practice, but you'll get the hang of it, I promise, if you do the practice. All right, now we do the range. So from bottom to top, are there breaks vertically? No, there is some point on my graph from the bottom all the way up to the highest y, which is what? 3. So from the bottom, which would be an arrow, which means -infinity, up to the highest y, which is here, would be 3, and it's an open dot, so it's a parentheses. Now increasing and decreasing is in 3 chunks again, because we use the x's. So this first segment is decreasing from, good, -5 to -3, both get parentheses because decreasing always gets parentheses. Then it changes direction.
Is there a break?
There is a break. That's why we stopped. So it's decreasing from here to here, which would be from -5 to -3. Then it comes back up again, right? So that would be increasing. From -1 to 1 always gets parentheses because a point itself cannot be increasing or decreasing. And the last one, this segment or this section of my graph here would be decreasing from 3 to positive infinity. We good?
We're taking the x value there
For increasing, decreasing, and constant, it's always the x value. The only thing that's the y is the range. And then what we're about to do. But from those things, it's the only thing is that y is the range. Okay, so now we go to these questions, okay, where it says find f of 0. So if I had an equation, I could use the equation, right? And I would take that and I would plug it into what variable? X. So what this is saying is, from my graph, give me the y that matches that x. It would be -4. Good. So you're going to go to where x is 0, which is this line here. You're going to find the point on this graph, which is here, and you're going to give the y that corresponds, which would be -4. So what's the y when my x is +3? 0, right? It's here. Go to 5. What's the y when x is 0? +1. Go to the next one. What's the y when x is -3? +1. And what's the y when x is +1? 1. This should be so very easy, and the things people do on this test are so weird. Like, they'll try to figure out what that equation is, and then they try to plug the value in. Like, don't do that, okay? 1, your equation may not be exact. 2, it's a total waste of time. Just look for the y that matches that x.
What if it's like, find the number 6, -2?
It wouldn't exist. So it does not exist. Yep. Questions?
So for what it says F3 and you pick 0,
Yeah.
there's not a point there,
But it's a solid, it's solid passing through that point.
so that's because it's infinity, right? So you just pick 0 because that's where it is.
Well, that's where that line crosses through at 3, right? It should be obvious. But just because there's not a solid dot there doesn't mean there's not a point there. There's a point there. It's just not a little dot. If that graph crosses through there, it's a dot.
So as long as that line goes through that
Yep.
point,
Yep. All right, even and odd functions basically overlap with some of your symmetry. So an even function is symmetric to the y-axis, even to the y-axis, like a parabola that runs through your y-axis. If I fold that from left to right along the y-axis, this is symmetric, and that's called an even function. The way we test, one, just look at it. Like, can I fold it on the y and does it overlap? Then it's a yes. The other way is if you're given an equation, you're going to replace any x that's in your equation with -x, and then you're going to simplify it. So if it was like -x squared, it makes the x go back to positive. If it's absolute value of x, it makes the x go back to positive, that kind of thing. And then you'll compare it to your original equation. If it is the same as your original equation or everything is the exact opposite, then it passes that test and it would be even. We're going to obviously do this with actual examples, but here's the idea behind it. The odd functions are symmetric to the origin, which means you either fold it along the y equals x line or the y equals -x line. Or like fold it down and over, like that's also the overlap. So something like x to the third, which looks like this, is symmetric to the origin. If I fold that down and over, they overlap. Or up and then over, they overlap, like you fold it into one little square, one little quadrant. Okay, and the test for odd is plugging in a negative, oh wait, hang on. Yes, a negative x, and each term changes sign. So if it goes away, it's even. If every term changes sign, it's odd. And then the last would be x-axis symmetry. And that is only when y is raised to an even power or an absolute value, and that cannot happen in a function. So none of our functions can have x-axis symmetry, okay? If you think about it, it would be a parabola turned on its side. If I fold that on the x-axis, that would have x-axis symmetry. And that fails your vertical line test, which means it's not a function. So none of our functions can be have x-axis symmetry, okay? But they can, like even odd, they can have neither. They could have both in not a function, but they could have both outside of functions. All right, so this one says determine if the function is even, odd, or neither. And again, if they are graphs, you know how to graph, you can feel free to do that. When we get into transformations, you should be easily able to graph something like number 8, okay? But for now, we're going to do the test even, odd. So even is plug in the negative x, goes away. If the negative goes away, then it's even. Odd, plug in a negative x, and all signs change. Then it's odd. And then obviously if it's neither, it is neither. So for x to the third minus x, I'm going to plug in a negative x in parentheses, because that will change my how I do the exponent. What is negative x times negative x times negative x? Negative x. And then what is minus a negative x? Plus x. So they didn't go back to the original, but do each of the signs change? Yes, meaning this is odd.
I thought you said if it's the complete opposite, it's even.
But that's if you change the y as well, so that test doesn't work. Yep. That test only works if it's a y equals. All right, 8. Plug in a negative x. What happens to the negative? Goes back to positive. Does this match my original? So this is even.
Why do you move the exponent down?
Because it still stays there. It's just the x that changes with the negative.
But why do you bring around the x squared as well?
Because negative x times negative x is positive x squared, right? And negative x times negative x times negative x is negative x to the third. The exponent doesn't go anywhere. Yeah. All right, then go to 9. 5 minus 3 times negative x. Negative 3 and negative x becomes positive 3x. Does it equal your original? Did both signs change? No, so this is neither.
So both signs change, it's
Odd.
and
Yep. Goes away, even, both sign change, odd, neither.
How would you graph neither?
Well, but you would that's just a line. Negative 3x plus 5. 1, 2, 3, 4, 5. It depends on the type of equation, how you graph it. Either. So that just doesn't have any symmetry when you're looking at it. That's all.
what does odd look like?
Odd has it's symmetric to the origin. So like a x equals y equals x line, that has odd symmetry. I mean, that's odd, so it has origin symmetry. You can either look at it by saying fold it on the y equals x line or the y equals negative x. Does it overlap? This one on the y equals negative x would. Or picture folding it in half, like bringing this part down and then flipping it over. That's the other way to look at it. Down and over. Will it overlap? I was going to say the only... All right. So now it's just taking it one step further because it's saying, is it even, is it odd, is it neither, like we just did? And then based on that, does it have symmetry? Okay. So the first one, I'm going to test to see if it's even, odd, or neither. So I plug in the negative x, sorry. Minus negative x squared minus 1. What happens with the negative when it's raised to the 4th power? Goes away. What happens with the negative when it's raised to the 2nd power? It goes away. The negative in between still stays though. So what's true about this when compared to the beginning?
It's the same.
The same, which means even, and even means what kind of symmetry?
Set. What?
Even means what kind of symmetry? The y-axis. Remember, odd is origin. They both start with O. Odd, origin, even, y-axis. There is no x-axis because it wouldn't be a function. There are x-axis symmetry in all graphing, but not with functions, which is what we're doing. All right, now to negative x to the third plus 3 negative x. What happens when I raise that negative x to the third? It stays negative, so it would be 2 times negative x to the third, which is negative 2x to the third, minus 3x. Does it equal the beginning? Are they both opposite? So this is odd, which has symmetric to the origin.
So it says you just put an arrow and origin.
Sorry, you both asked me a question at the same time. Go. Go ahead.
What symmetry would be there at? There wouldn't be one.
If it was neither, there would be no symmetry. Yeah.
Well, it says you just put an arrow and origin.
Well, I mean, it would be like maybe 2 lines, and it would be even, and then it would be y-axis. Or it would be a 2-part multiple choice where you would say it's even with y-axis, it's even with origin. It will do something like that to throw you off. Yeah. Or,
When you drew a line, on the questions above, when you were
all right, the easy part is zeros of a function. Literally set your function equal to 0 and solve it. We know how to do these, okay? It's like making f of x 0. They are called zeros, okay, because it's where f of x is 0. They are also called solutions. They are also called roots, okay? They are also called x-intercepts if you put them in coordinate point form. That's intercepts. All of those mean the same things. Zeros, solutions, roots, x-intercepts. On your graph, it would be where it crosses the x-axis. Those would be the solutions to that equation. All right, so you literally replace your f of x with 0. And then what? I gotta factor it, right? So I can either do first and last, or I could do trial and error here because they're prime, 2x and x, and it would have to be -1 and -1. And I'd end up with a split and solve, and I end up with +1/2 and +1. So from a graph, it would cross through those 2 points. What?
It would be -2 and -1. Because it needs to equal 3.
Yeah, when you do the outer and the inner, this would equal 3, right? Outer would be -2x, inner would be -x. That's what gives you the -3x. I didn't do first and last. I did trial and error. Yeah. All right, then 13, same thing. Make your f of x 0. Now, what's your first step going to be?
Get rid of the
Denominator. Yeah, and how do you do that? Multiply it. If I have a fraction and it's equal to 0, what's going to happen when I multiply by that denominator every single time? It goes away. So you could literally just ignore it, because if I multiplied it, like a shortcut, this is not like we're not changing the way we do math. You would multiply it and it would go away every single time. So if you have a fraction, you really just have to set your numerator equal to 0. I'd get -5 equals 2x and x equals -5/2. And again, this graph, which is a weird one, it would cross through your x-axis at -5/2. That's what the 0 would look like. Questions? All right, so due date on this assignment is obviously tomorrow. Should I see you tomorrow? Should I not see you tomorrow? I will move it, okay? But for now, I would say just get it done, because you don't want to have to deal with this on top of all the other stuff next week too, okay?